Hey everybody, this is Miss Cologne here, and I'm going to show you a review of Unit 1, Part 1, which also talks about scale factor, scale copy, corresponding sides. Whenever you're dealing with a scale copy, you need to keep in mind that you typically have to have an original image and then usually a copycat of that, whether it's an enlargement, goes bigger, or reduction, one that's smaller. So, mainly part 1 in unit 1 focuses on scale factor, but in order to know how to find the scale factor, you got to know what that means. So, we're going to go back to our definitions. Definition of a scale copy: it's just a copy that corresponds to all the sides to the original image. Okay, now there has to be a pattern for that. That's basically what we're saying. Okay, and to find that pattern, that magic number, we use what's called a scale factor. That's that magic number you have to multiply all the sides, not adding or subtracting. And so we usually use a formula, just a cute little formula. We call it the no formula because it is going to be the measurement of the new length, which is your scale figure, divided by the old length of your original figure. Okay? So let's go back to the example given. I'm giving you a shape. I'm telling you that this is your scale copy of this one. So if this is my scale copy, this is originally my scale, or this will be our, not our old. This is our new, okay? Because if this is my original image, that means this one is my old. In order to find the scale factor, if I'm asking you, how do I find the scale factor? You need to use your formula, new divided by old. Now this is where you need to label your corresponding sides, because we already know they're scale copies of one another, so it really wouldn't matter which side length you use on one of them. Just make sure if I'm picking this side, you need to pick the exact matching side corresponding to it. So the only one that matches to this side is a 12 on this side. And so your new is your 12. Your old value is 8. Now, typically I want this problem reduced. So if I'm taking 12 and 8, you need to simplify that and divide both top and bottom by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Notice that this value is 1.5. It is bigger than 1. So when your scale factor is greater than 1, that is where your scale copy figure is bigger than your original. And we can see it here. Okay? We're going to do another one. So the next one is a triangle. Now, say you have a triangle or any shape, and it doesn't look like they're aligned. You can redraw it out so they both are facing the same direction, they're posed the same way. For now, I'm going to leave it like this, because I do know that on this triangle, if I'm missing the longer side, the hypotenuse, that means I know I'm missing this side, the longer side. So I know from here, this will be the bottom of your triangle, and this is on the side to the left. So I would not consider this to be the left side, because if I were to rotate it, this now looks like the longer side for the original, and now this is the bottom and 5/2 is the top of the side. So I need to find my scale factor, and again, scale factor is new over old. Now, you can use a calculator. I'm just going to label it here. Assuming, again, this is my scale copy. So this is my new, this is my original, so it's my old. You can pick any other side length. So if I pick this 12 as your side length, you need to align it as if I rotated this back and your 6 is in the bottom. It corresponds to 12. So now your scale factor, your numerator, your new is going to be your 6, and your old is 12. Now again, you can reduce this fraction because I do want my numbers simplified. I can divide top and bottom by 6. So 6 divided by 6 on top is 1. 12 divided by 6 is 2. Now that I have a fraction, Now, if my fraction or my value is less than 1, then you should know that your new scale copy is smaller than your original. Even though it doesn't see it, it's not shown that way, these values are smaller than these. Okay, we're going to do one more. This is where it gets complicated because no matter what, we can't avoid fractions, right? But the process is still the same. So I need my scale factor formula. That's new divided by old. Be careful how you label this now. So it doesn't matter now which number, like I said. So I'm going to pick 10. Let's pick 10. And the side length that corresponds to the 10 will be the 25 halves. So now, this is your new, this is your old, okay? Unless I tell you which one is new or old when I label, assume your right figure is always the new, your left is always the original. So now, 25 halves is your new. Your 10 is your old. So, you would need to use a calculator for this part, or you can type this in the calculator, or you can just work it out by hand. I'm going to show you what it looks like by hand, but please use a calculator and see that we get the same answer. So I got to do 25 halves divided by 10. Okay, now one thing about fractions and division, they don't mix. You cannot divide a fraction. So I'm going to rewrite this whole number with a 1 because every whole number can be written as a fraction. And then I'm going to use what's called the KFC method. Keep, flip, change, or how I've known, keep, change, flip, or skip, flip, multiply. Okay? Keep means I'm going to keep the first fraction the way it is. Flip means I need to rewrite 10 over 1 to its reciprocal. That R word we learned, right? Flipping 10 over 1 now becomes 1 over 10. And now we're going to change my division because if I'm rewriting this as a reciprocal, you have to do the opposite operation. So now, if you multiply straight across, 25 times 1 is 25. 2 times 10 is 20. Now, 25 times 20, I can simplify that. Okay, we can reduce these top and bottom by 5. And if we do that, 25 divided by 5 is 5. 20 divided by 5 is 4. And that is about as far as I can go. So that is my scale factor for this image. That is all for part 1. Stick around for the next video for part 2 on scale drawings. Have a good evening.